All right, my name's Tom Akuch. I'm a solution engineer with Hortonworks.
And I'm Oleg Zhirkowski, principal architect with Hortonworks.
And today we're going to be talking about wiretapping your application for knowledge using Hadoop. So we're all, I think, somewhat familiar with building applications. Show of hands, application developers in the audience? Okay, good, good. So we're going to take an application, and we're just trying to figure out, right, how can I introduce Hadoop into the overall architecture of this application, and what's a good way to derive some value out of Hadoop.
And it's not just introducing Hadoop into the picture, it's what value does Hadoop bring in the picture of a real everyday application of today.
Right. So we talk about the application development dilemma, and I'm sure all of you are kind of living this reality. 80% of our code today deals with persistence of 20% of our data to relational databases typically, or maybe NoSQL stores. Increasingly NoSQL stores are rectifying this, but the general 80-20 rule applies here, that a significant amount of our data is either not being collected or being rolled through log files and only really used for problem diagnosis. So this is kind of the theme that Oleg and I talked about in yesterday's talk, so we're going to kind of be picking up from that theme. For the remaining 20% that we do collect, again, we're not getting as much value out of it based on the amount of effort that we're putting in to collect it. So how can we introduce an easy way, right, to collect all of the data that is generated by our application and store that for future use? That's really the kind of the question that we're posing. So our example from last talk, and where we kind of left the last talk off, was around an application for ingest, right? So this is a typical enterprise integration flow. We've got data flowing in, and there's an awful lot of data, right, that we can capture as that data is flowing through our ingest.
So, for example, and I'll talk about this a little later on in more details, but if you look at any log file of today, or any event data, or any machine data, with Hadoop you keep hearing this term unstructured data, but is it really unstructured? I mean, I'm kind of asking you guys, if you look at any log record, does it really have no structure whatsoever, or does it have some structure that might not be well defined, but still exist there, right? So we can kind of look at the log record, or any event record, or any message, ACH record, CDR record, anything of this, and you can clearly see that there are distinct fields, right? And I can say, well, listen, maybe it will be interesting to know how many unique values in those fields, how many different values are per field, access values of each field independently from the record, and things of that nature. So this is statistics that are available to us during the ingest. This is all the information that's available to us during the ingest. And as Tom was pointing out, that's where the 80-20 rule essentially applies, is that this information just went through our ingest and was absolutely lost because we never collected, we never paid attention to that. Some of this information, like for example, record count on the compressed file, it would have been just a simple counter to maintain and store it as a first byte or something like that. And there's many examples of that, and I'll show them to you later on today.
So in general, these are cross-cutting concerns. So how do we address cross-cutting concerns without disturbing, the existing integration flow? And that's really what we're going to look at here. So we're going to take, a modern application. So most modern web applications that are out there have a web front end that is kind of JavaScript based, and then a back end that it's more service oriented, right? Where that service may be basically a gateway in for a process, right? A series of steps or an integration flow, if you will, to actually serve the request against that service.
But the main point here is that you have an existing application, right? So, of course, if we had known everything that we know now, we know that yesterday, then sure, we could have designed it with all that in mind. But the problem is we don't, and we end up with the existing application. And right now, we need to figure out the way how to wiretap, how to actually sort of start getting all this information without disturbing the existing application, because that should run as it existed, almost to the point where whatever we decide to introduce, we don't have to retest the entire app for that, because it should not disturb it in any different way. So, and what we're going to be talking about right now is various different techniques that could be used and how Hadoop plays a role here to accomplish that.
So the name of the talk was wiretap. So we thought we'd kind of just briefly cover enterprise integration pattern for wiretap. Basically, as you can see, what we have is a pipes and filters type of architecture, and the pipe itself can be tapped, right? So essentially, I'm going to take the messages that are flowing over that channel, and I'm going to publish them maybe to another consumer, or to a pub sub type model where I can have multiple consumers.
Right. And in this particular case, as you can see from a diagram, the flow will go from left to right as it's supposed to, but something is tapped in, and you start grabbing this information and doing something else with it.
So this is, as I said, this is the way a lot of kind of service-oriented architectures are designed, right? You've got a series, an integration flow that's kind of behind that endpoint that is called by the front-end web application. And as I said, there's a whole set of patterns around enterprise integration. Hopefully you're all familiar with these. We're going to be using some of the symbols from the Enterprise Integration Patterns book.
As well as the terminology.
As well as the terminology in this talk, yeah. So just to quickly cover those for those who don't have a background, we've got transformer, where we're basically transforming a message from one format to another. We've got and these are really steps or stages, if you will, within your event-driven architecture.
Right, the filter, the router, the splitter, the aggregator. These are all different things that we're going to be using today at the conceptual level. Sure, I'll demonstrate it in one of the frameworks that I'm using, but these are all different enterprise integration patterns. This is just a few. There's much, much, much more of them, but there's just a few that are kind of sort of relevant to this particular discussion.
But the general idea is that you've got an application that is somewhat distributed, right? It may not be distributed physically, but logically it is, right? So I'm flowing messages through a series, a flow of these patterns that enables fulfillment of the request. So we're gonna actually dive into a specific business case. So we started off with the example of the ingest application, but really for this talk we wanted to give you something a little bit more meaty. So kind of at a high level, how we're positioning Hadoop and the value around Hadoop. You may have seen these data types elsewhere, but we see an awful lot of companies kind of picking up on new data types, right? And there's 6 of them that are most common that we see that are listed here. And this is where they kind of start their Hadoop journey. So sentiment is a really good example. So that social media data types, clickstream, for web logs, sensor or machine data. So this is observations that are being made. The device-connected internet, where 50% of the IP addresses out there are devices, right? And they're communicating back home, with their diagnostics. Geographic, right? So your cell phones, hitting mobile towers right now, and sending geographic positioning. Server logs is the one that we're going to be focusing on today. So, specifically, these are logs of what's happening within your application flow that otherwise you would only really use for problem diagnosis, right? An application developer or support person would go in and look at these logs in the event that there was an exception, right, or some type of problem with the app. We've mapped those to a set of enterprise use cases here, and the one that we're going to really dive in on is fraud, fraud detection or fraud prevention in the financial services vertical. But you can see that these data types really cross multiple verticals, right? And that there are tons of use cases similar to the one that we're about ready to dive into here. So a little bit of background on fraud prevention. We are doing an engagement, so some of the work here is coming from an active engagement that we have with one of the major financial services institutions. And really the problem that they're faced with is that they're kind of tapped out on capacity for their credit card authorizations and credit request processing flow. So they have a specific SLA that they need to satisfy for all credit card requests that come in, and they need to give a yes or no answer by the end of that time period in order to authorize or deny the request. That all goes through a scoring engine, which is part of this flow, right? So they want to score the request, and they want to look at that request within the context of a lot of other requests, right? And be able to determine whether or not they should authorize or deny based on that score. One of the things that they're looking at Hadoop for is currently they're only flowing monetary transactions through, right? So they want to flow non-monetary transactions through as well. And these are typically batch transactions that might come out of their enterprise data warehouse. Things like I created an account. I changed the address on account. I changed the name on an account.
Basically, the bottom line is they want to start storing and analyzing any type of meta information, any information that actually goes through their systems, not the ones that they designed for ahead of time.
Right.
So essentially, they have an existing application that does give you credit and everything else, and everything works as expected. But now they want to add additional thing to that. So it's not like a brand new development. What's brand new is that additional part that's supposed to wiretap into existing stream of the process flow and do all this additional processing.
Yep. So the basic process flow is shown here, and it doesn't get much simpler than this, right? A credit request arrives on a gateway. It's sent over a channel to an event-driven consumer that picks it up and processes it and issues a response. I mean, very, very, very simple integration flow. But it's important to start here because what we're going to do is now build upon that, to kind of expand that flow for some cross-cutting concerns. Cross-cutting concerns within this flow that we talked about are credit scoring, right? Fraud detection. So not only performing the score, but also detecting fraud based on that score, and the score of that within the context of a lot of other transactions, right, that are being flown through, as well as additional data, right, that's available during the process flow. Very similar to what we talked about, on yesterday's talk.
Right. So right now we're going to switch to a demo, basically, kind of at the very trivial. It's at the very high level, but we don't really have a full-blown application that does the credit processing. But it's a good thing that in modern languages you can emulate a lot of things very quickly. So what I'm going to do is kind of run you through that last diagram that Tom was just showing and describing. So we have a pre-existing flow, and then I'm going to expand on it, and you can see. So my goal is that I have some Java code that I've written. Yesterday I was actually changing Java code. Today my goal is not to change Java code. My goal is to say I have an existing app. I don't want to change that. I want to make sure that that flow remains the same. But right now I have a problem. So right now I have this credit request processor that basically issues gives you a create response for your create request, and it does it based on some randomization, right? So, but right now I want to make it a little smarter. I want to be able to introduce the scoring part to this particular thing, right? And I want to be able to score it based on, again, I just came up with this requirement, but it could be anything else. So my rule is that if your credit score is higher than 740, then you're okay. But if the credit score, but if you're only issued the first request, basically the first 3 requests will get approved right away without even evaluating the credit score. But if you got more than 3 requests, then I'm going to look into the credit score and see if your credit score is good enough, and then give you approval or not. So the interesting thing here is that now I need to know how many requests you made before, and maybe get access to some other information like the data, the date when you submitted a request, or other things. So like some of the things that might come from the HTTP application or something like that. So now I need to be able to store the data and then implement this whole thing with the credit score rating, right? So here's my application. In fact, I'm using when it comes to wiretap, there's many different ways you can accomplish that, right? I'll show you a few today. For this particular demo, I'm going to use a framework called Spring Integration. I'm kind of biased to use this framework because I'm one of the core developers of it. But there's many other frameworks out there. Again, Apache Camel, Java Proxy, and things like that you can use. Or within other languages, there are other things available to accomplish that. So here's a typical Spring Integration flow configuration. And as you saw from the diagram, this actual diagram derived from the existing configuration. So we see exactly what you saw on the slide, right? So I'm going to run it real quick. And I'll show you the whole code for running it. It's very simple. For those of you who are familiar with Spring, create your application context, get your bean, invoke it, and then you're done, right? There's really nothing there. So we have create request gateway, request credit for me, and then get response and print response.
And you see that it was approved or granted mainly because it was one of the first 3 requests that he's made.
But in this case, this is like a simple process. Right now, no matter how many times I ask for the credit, I'm going to be giving it to it, right? So imagine the banks, imagine the bank evolves, and now they say, no, I don't want to give credit to just anybody who comes from the street. So I want to be able to be smart about that. So great. So now let's build it. So the first thing we need to do, we need to be able to start storing some of the data that that's flowing through our application. So right now we're using basically what goes through the application is the Spring Integration message, but imagine that it came from HTTP, where it would typically come from, for example, right? So you would have like a lot of HTTP headers there and a lot of other meta information that might or might not be available. The whole beauty of Hadoop is that we sort of store data indiscriminately, and then so maybe something that we didn't account for today is going to be valuable tomorrow. It's thank God we kept that data. So that's the whole purpose of Hadoop, and the whole difference between doing it like the database way, where we have to pre-design ahead of time and then realize, oh, we made a mistake, we should have collected that piece of information as well. So what I need to do right now is wiretap into this stream and start writing data into Hadoop. Okay, so how do I do that? So as you can see, I have a gateway, and this is where the request comes in, and I have a channel, which is basically the component through which everything goes through, right? So where do I wiretap? Right into that channel, right? So
we're going to intercept the flow and basically introduce a wiretap. And we're going to route that to a separate channel.
So we have basically I define a wiretap element, right? And right now I can do it. Call it the channel, a JFS request channel, right? So right now the request, my object will come to that channel, and it has to be distributed to another event-driven consumer. So first of all, I already created a wiretap. So right now I can start building a flow into this wiretap that's going to be executing sort of in parallel with this, with my existing flow. So I'm going to receive a message. The message contains my create request object. So I want to write that create request object into a file, into HDFS, right? So first of all, I need to convert it, basically transform it into something that is serializable, like a string or something like that, right? So that's exactly what I'm going to do. So I'm going to create again, this is one of the beauties of Spring Integration is that when you start thinking in terms of patterns, then there is a component for each pattern. There's a component that represents each pattern, so you can just configure that, and there's a certain contract defined within that. So let me just start cut and pasting this way I don't have typing errors. So here's our input channel, right? And the output channel will be, our HDFS sync channel. right? And the only other thing we need to do, if transformation process was very complex, then we could write our own custom code. But since in this case transformation process is rather simple, I can just use expression and say basically.
So we're going to take the message and basically put that to string,
Right.
and add a new line,
And
so that, you know, it shows up correctly within the file. So we're
Right.
creating a log file here, right?
the funny thing, we don't really need to add a new line, but just for visual visibility, for the demo purposes, it would be nice to see him all like this, right? So typically that extra byte, just waste of space. So anyway, so we got transformers. So now we're going to use, again, I'm going to write file locally, but you know, it could be used. I could use a different component, write it into HDFS because it's just a sync part, right? So I'm going to use a channel adapter, so I don't have to even write any code to write the file. And its channel is going to be this HDFS sync channel. I actually have to explicitly define it. Right, and then there's a few more things that I would need to define. So directory.
So we need to provide the file path.
Right, and
So if we were writing to HDFS, it would be based off of the root.
file name generator expression will be this. And one more thing I need to provide because I want to make sure that it appends to the same file. So, and in the Hadoop case, you would have to keep the data stream open for that because there is no real append yet or ever. But in this particular case, I can just do mode append, right? So we're done with this. So right now, if you look at the configuration, what has changed is that we have a wiretap channel, right? And it's basically wiretapping into this whole new channel, and we literally have a whole new flow here. So this channel. Actually, let's do this. To make the literally, I don't need to do that, but to make the diagram look much better, I'll define this channel explicitly. And if you look at the diagram right now, we have this, okay? So this editor recognizes it. So right now we have one flow that's going the normal way, right? That's our create passing, that was our existing flow. And right now we build this thing. The only one less problem that we have to solve, but before we even solve that problem, let's just run it real quick and make sure that we have everything working. Okay? And at this point of time, we have to have this brand new file because I deleted it before. Actually, I didn't delete it before, so let's delete it. I'll just run it a few times. Right, so if I refresh, we got 3 records there, right? So right now you can see pretty much a Spring integration message structure. So there's a payload and headers. And you can see that in this particular case, there is not much of interesting headers. But if it was a JMS request or if it was a HTTP request or something like that, you would have a lot of interesting information that might be interesting right now, might be interesting later. And right now, because this is what you would write into HDFS, you really have you basically that 80% of data that you were throwing away, you're essentially storing it. So that kind of addresses that other concern as well. So now the only other thing we have to fix here is that, remember we said that the wiretapping should never disturb your process. By default, wiretap within this framework is synchronous, which means since I'm splitting kind of the flow, it goes, does one thing, and when that's completed, it goes, does another thing. Now, would you agree that it's supposed to happen like that? No. So it has to happen asynchronous because if something is blocking in this wiretapping flow, it will affect the existing flow. So we need to make sure that that doesn't happen. So the way to do it, we just have to make one of these channels asynchronous, right? So we're going to define a thread pool. Right? And once we did that, so we can just modify this channel to which request comes into a wiretap. And
by the way, while he's doing this, there's a very interesting project out there you may want to look at if you're a Java developer. It's called Weave, and this basically makes resource containers in Yarn look like threads to a Java application. So you would be able to, we're going to talk about how you'd be able to take this application and deploy it in multiple places, but just kind of giving a little bit of foreshadowing there.
So I just ran 2 more requests. It's still granted. So basically everything is working. But right now I'm starting to collect data inside of HDFS, let's say, right? So I'm having more records, right? So, all right, so we addressed this one concern. So right now, let's build the scoring engine, because now we wanted to be able to introduce the scoring engine and say, listen, now I don't just want to give a credit because he asked me that, right? I want to be able to receive the request, send it to a scoring engine, and then basically aggregate my response that I might say that, you're good for credit, but the credit scoring engine says, well, maybe not so good. So I need to be able to aggregate that and eventually issue the final response, right? So like a pre-approval versus a final approval. So let's go back to our file, and all we need to do is basically, so we have this service, which is our credit request processor, right? We're just going to add another service, which is going to be our scoring processor, right? And as you can see, everything stays the same. It's going to receive requests from the same channel, right? But the problem is that this channel right now is it's a direct channel. It's a point-to-point channel, right? So wiretapping could be accomplished in many different ways. Wiretapping like this is one way. Another way that we should probably architecturally fits better here for this particular purpose, for scoring, is a publish-subscribe consumer, right? So in order to have a publish-subscribe consumer, we need to have a publish-subscribe channel. So we're going to change this channel to publish-subscribe, because right now in the point-to-point model, only one consumer receives the message. In the publish-subscribe, everybody who subscribes will receive that message. So we're changing this channel to a publish-subscribe channel, again, without breaking any contract with anything within the existing system, because the original flow will still get that message, right? And we can actually, there's a way to control the order in case if that's important too. But in this case, since it's asynchronous, it's really all not that important, right? Now we're basically adding another consumer scoring engine, and the only thing we need to do is change the implementation to a scoring engine I have, right? Yeah, so the scoring engine. So, but right now we have an interesting situation. Before, this create request processor implementation was producing the reply, and since we didn't define the output channel explicitly, it was sending it to internal reply channel that was generated by the gateway, right? But right now, with this particular configuration, we need to continue, because right now we have 2 outputs, right? And somewhere they needed to be aggregated. Kind of look at it, that splitter aggregator is really the original name for MapReduce. So we mapped 2 requests, and right now we need to reduce it, right? So let's define an aggregator. What is it called? Create response. All right, so that's pretty much it. So that's the beauty of another beauty of sort of Spring integration is that, I mean, aggregation is a very complex problem to solve, but it's been solved here by the component that's already been implemented. So we can simply define it, and the whole contract and everything is going to be enforced by that component. And the way it's going to be done, you might want to ask, like, how does it know that this message should be correlated to this message, right? So the interesting thing is that you can define it anywhere. You can define your own rule. But in this case, if I use a publish-subscribe channel where this split is occurring, all I need to do is say apply sequence equals true. And what it does, it creates basically additional headers, and we can see them in the message, which will be correlation ID, correlation sequence, and things of that nature. So now this information is going to be used because the 2 messages that are going to arrive to the aggregator are going to have the same numbers assigned to them by the publish-subscribe channel, and therefore aggregator will use a default rule to correlate them. So now let's run this request and see what happens.
So our aggregator is what is actually looking at the credit score that's returned, as well as the number of credit requests that have been made previously.
So the demo guys aren't smiling today, so let's see what happened. Okay. So convert value of type Hadoop create a score to require type Hadoop and create response, no matching. Oh, all right. So I didn't do something important here. What I didn't do is I talked about the output channel, but I missed to define the output channel because I need to define the output channel from both create processor and scoring processor to be the input channel aggregator. So let's fix this real quick. And do it again the same right here. Okay? And now everything should work fine. All right, so now let's look at the output. So right now, you can see that there is a processing create request for Alex Rakowski, then create response was granted, right? Then there is a reprocessing create request, because that comes from the aggregator, and request was still, my request was still granted. Why? Because I happen to get a high credit score. Let's run again and see if it's, and the credit score I'm doing is basically using Java random. So here we go. I got a low credit score, and because I have too many requests already, it flagged me down. So all of a sudden, something happened, and without changing the existing process, I was able to introduce credit scoring. Now, Tom earlier said fraud detection, right? So now, with what you saw right now, how difficult do you think would it be to add the fraud detection to this? We already have a pop-up channel, so all I would need to do is literally copy one of these guys, right? So first of all, let's quickly look at how our flow looks like right now.
Create a different aggregation channel.
So I would simply do this and add different class or different implementation, and all of a sudden I'm splitting my flow into 3 subflows, so to speak, right? And then the aggregation will be between 3 components and so on and so forth. So now the fraud component can make its decision, the scoring engine can make its decision, and the regular process make its decision, and the aggregator is like the final approval, will evaluate everything, all without ever changing the existing flow or disturbing it, okay? So at this point of time, we're done with this demo. So let me just fix it so it remains in a working state. Okay, and going back to the slides.
So this is what the flow looks like afterwards, and you can see, you know, we're actually wiretapping right within the credit process, the credit request process flow, and flowing that intermediate data, right, that message data that's happening between the components of my application into Hadoop. And you know, it's important to note that not only can I, you know, use this data as part of the processing, right? So you know, I might choose HBase over HDFS. You know, I could make certain decisions there, in memory alternatives as well. But also, I can now begin to look at how do I, you know, one of the problems that this financial services institution has is how do I test the rules for my fraud detection, right? So if I have all of this data, this exhaust data that's being generated by my app in HDFS, ultimately, then I can actually test, you know, my fraud detection rules. So when I make changes to rules, I can see that they you know, come up with the right outcome. And more importantly, not only can I run this for my monetary events within the existing J2EE infrastructure that I have, using, you know, message queues and other things like that, but also I can take the same code, right, and deploy it within Hadoop.
Basically, you include that code within the MapReduce. So now you get this batch processing. Basically, take this jar file, move it right there into the class path, and everything works the same way.
And I can run all of my, you know, basically my account changes, right? So name change on an account, credit limit change on an account, so on and so forth. Run all that through using the parallelism of Hadoop to basically support you know, the same flow, but with a different set of non-monetary events.
Right.
And that improves the scoring.
Right.
Forward.
A few more use cases. We had another use case, which is a very interesting use case, probably actually a very interesting use case, and we wanted to do it here, but because we had only 40 minutes, we couldn't find the time to do it. So, but the thing is that Tom and I actually did this one in particular last year's Spring One conference, and it's recorded in InfoQ, so you can watch the recording. And basically, what we did is think about we had like a
Get a simple web app.
Simple web app,
Yeah.
and
We had everybody in the audience
to.
hit it.
We actually had everybody in the audience
Yeah.
hitting it from the iPads, from iPhones, whatever they had, right?
Yeah,
Because we were emulating the kind of a kiosk, right? And we wanted to know that what the user experience was based on the devices, because I specifically designed the screen to be nice for the laptop, but probably pretty crappy for little devices, right? And we basically play this scenario that say, listen, I just got a budget to improve, to design a user interface, but should I do it for iPhone, tablet, Droid phone, or something like that? How do I get this information, right? That's the information that I'm throwing away, because that HTTP request comes into me, I extract what I wanted to extract, which is business data, and then throw the rest away. But as soon as we wiretap into this stream and start collecting HTTP requests and the headers, right, we essentially, with HTTP headers, we essentially start collecting all this information. And at the end, you'll see I'm running a MapReduce. And there was a little bug, but I think iPhone won at the time, right? So that was the deal. So I'm just going to post a reference here.
If I had never collected that data,
Yeah.
right, I wouldn't have been able to answer that question. So, it's a good example. If I didn't know that question was going to come up, but if I had just been throwing that data away, then I would have never been able to answer the question, right? So that's kind of the idea around, this whole talk is,
Right.
Collect this data, this intermediate data that's being produced by your application and save it. And, likely you'll be able to use that.
And one
in
more
your
use
analytics.
case, one more use case is where we left yesterday, kind of getting back to where we started this presentation and where we left yesterday, is this ingest, right, that kind of one of my favorite topics to talk about, because, unique values, values per field, basically looking at the unstructured data that maybe it is actually structured. Let me show you a quick demo, because this one will take 2 seconds, right? So I'm going to ingest a file, right? That's part of something that I'm playing around with right now, kind of a designing see if something comes out of it, right? So I'm going to write a file, right? So I'm writing 100,000 records right now, but during the ingest, I'm actually gathering all kinds of information for that, right? So I've written the file, right? And it's kind of right now my proprietary binary format, but check this out. So now I'm reading the stats on this file, all magnified, right? So first of all, you can see how quick it is, right? No, because I did not read the entire file to get those statistics. Those statistics were stored as the first 163 bytes. That's all it took. But look what I get right now. With this binary format, I know that what my original file was. Remember, when you compress the data, you lose that information right away. I know how many records was there, right? I know what the compression size. So right now, I know I can calculate the compression ratio, right? I know how many different record types, because I designed that was embedded into my implementation of the parser, right? But here's some of the more interesting information. So since this unstructured data actually had some structure, and I was parsing individual fields, so now I can actually look at the fields and say, okay, well, interesting statistics here, because I can see that my first field only has one unique value, which means it's the same value all over the place, right? Interesting, so that's the same sequence number. Now, the second one is actually a timestamp. So think about the importance of this number. So I know that within this 100,000 record covered 3 seconds, right? So if I, let's say, ingested 1 million records, right? And you can see that from this number that you only have variation of 2, that there are only 2 unique values, then you can immediately calculate the ingest ratio that was, for example, 1 million divided by 100,000 per second, right? And for example, look at the field 11. That's the IP address. Now, it tells me that there's 98,000 unique IP addresses within this particular file. So that tells me that, I might look at this information and say, well, listen, is my IP distribution proper, or maybe I should do some kind of a rule change on my DHCP server and things like that, right? So,
so the idea is these files, they get very large, obviously,
Right.
as you're creating them. So if you can, answer some of these questions that are common for analytics, counting specifically, out of stats, that's going to be way more performant than scanning through the entire table just to do a count.
And what a perfect timing. We have 12 seconds. So guys, questions? Yes. Can you come to the microphone, please? All right. You can ask questions after that, like we'll be outside.
So this assumes that the app that you're trying to wiretap has been built with patterns and some kind of a framework that you can tap. What about if it's not built that time?
Yes, sorry about that. I promised you that, but I ran out of time.
As well.
I can step out and show it to you. So Java proxy is another way of accomplishing the wiretap. So it would be, Yeah, I literally don't have time, but I can show it to you. It's literally a few lines of code, and I plan to do that, but literally run out of time. So
that uses
thank you guys. We'll be around.